The properties of the wave, specifically diffraction. The diffraction, different waves hit the barrier with different size gap. Diffraction is maximum when the wavelength is equals to the gap size. The waves will diffract. In which diagram does the greatest spreading occur? Diffraction is maximum when the wavelength is equal to the gap size. It will, so when I draw the patterns, so this is the term maximum diffraction means greater curvature. This is what we observe. This will also be curve, but small curve, like less. This will only the edges will make a curve. So maximum diffraction when the wavelength is equals to the gap size. If gap size smaller than the wavelength, then spreading will occur, but comparatively less spreading. Like, what is the term? Diffraction means spreading of the wave when it passes through the gap. So this wave, when the wavelength is equal to the gap size, maximum spreading means the wave will travel in many directions. This will also spread, but then less diffraction. So where it is curved, this is curved, this one is also curved, but because it cover a greater region, so greater curvature will be there. It is maximum when the wavelength is equals to gap size, and when the wavelength is bigger than the gap size, it is very small diffraction. When wavelength is smaller than the gap size, here wavelength is 1 centimeter, gap size is 2 centimeters, so small diffraction. Wavelength is equals to gap size, so maximum diffraction. If wavelength, for example, was bigger than the gap size or gap is smaller, then also diffraction occur, but small amount of, compared to, it is maximum when the wavelength is equals to the gap size. So either it should be equal or the gap should be smaller than the wavelength for maximum diffraction to occur. The diagram represents a plane wavefront being diffracted through a gap. Which pair must increase the amount of diffraction? What must be done to increase the diffraction? So we should increase the wavelength and decrease the, make a narrow gap. So when the gap size is equal to or is smaller than the wavelength, then the maximum diffraction occur. So increase the wavelength should be greater and the gap size should be smaller, so maximum diffraction. And how we represent maximum diffraction? We represent by curved wavefronts. Question 8. What is the name of the effect that caused the wave to reach point P? So that's called diffraction. Question 17. A small boat in a harbor is protected from wave on the sea by a harbor walls. Like the harbor walls are protecting the boats. So these are the harbor walls. Some wave can curve round a harbor wall when reaches the boat. What is the name of this effect? So 17 is A, that's right. Because when the waves spread out, it become curved. We call that as diffraction. Dispersion, you will study dispersion. Dispersion is actually when the white light spread into 7 colors. That part we will discuss later. But when white light split into colors, like violet, indigo, blue, green, yellow, orange, and red, we call that as dispersion of the light. Question 20. We don't want the waves. How can the gap be changed so that the waves are less likely to reach the board? We want to reduce the effect. So if we want to reduce the effect of diffraction, we should increase this gap size. So when we increase the size, as the gap size is increased, then it reduces the diffraction. The wave will not diffract when it's a larger gap. So in this question, a loudspeaker produces sound waves of a constant frequency. What is meant by frequency? So the definition of the frequency, it is number of waves in 1 second, or number of vibration so number of waves or number of vibrations in 1 second, that's called frequency. Then the sound waves travel in air through a barrier with a small gap at its center, represented by compression. Like these wavefronts are representing compression, region of high pressure. What is meant by a compressor? So what is meant by compression? It represents the region of high pressure where the particles are closer to each other. The width of the gap is smaller than the wavelength, means this gap size is smaller than the wavelength. On a figure, draw a pattern for the compression after the sound waves have passed. So these are compressions, all are representing compression, means the wavefronts. So we have to draw and show a maximum diffraction. So when you are representing a maximum diffraction, so using a compass, you can draw this, and keep one thing in mind: when you draw the curve, the wavelength does not change. So means, example, if this, according to paper size, if this was 2 centimeter wide, then you should draw the other wavefront also 2 centimeter away from the first one. So you have to represent a maximum diffraction with equal spacing. The barrier is adjusted so the gap become wider. So now we adjust the barrier and the gap is wider now. Describe how this affects the pattern of compression after the sound waves have passed through the gap. So what happened if we increase the gap size? The pattern of the diffraction. So it will be less spreading or less diffraction. It decreases the diffraction, that's right. Or diffraction will decrease. Or less spreading out. Because spreading of the wave around the obstacle or near the edges is called diffraction. So it will be, the answer is, because if the gap size is larger than the width, than the wavelength, so we have less diffraction. Or less spreading. Another question related to diffraction. The wave in B approaches the barrier that has a large gap at the center. And you can see that the wavelength is smaller. The distance between the two successive wave fronts is smaller as compared to the gap size. This gap is much larger. The gap of the barrier is larger than the wavelength. On the figure, draw the pattern formed by three crests after the wave passes through. Basically, we are representing the wave fronts. So wave fronts represent the identical point of the wave. So all of them are representing identical points, like all are representing the crest. So when you want to show a small diffraction, so how you will represent? First a straight line, but near the edge it will be slightly curved. And again, the wavelength should not change. So how you will represent the wavelength does not change? So when you draw the wave fronts, so if this was 2 centimeter according to paper size, so you will draw 2 centimeter each of them. Keep that in mind. Like this gap, this distance should be equal to the original one. The wavelength does not change. Only thing which changes is the direction. So the wave spread. So when you are drawing first straight line and then near the edges slight curve, this shows small diffraction. When completely curved, it shows maximum diffraction. Is it clear, this point? Now the water is added to the tank and the speed of the wave in a deep water is greater than the speed of a wave in a shallow. The frequency remain unchanged, but its wavelength different. State and explain how the wavelength in a deep water has changed. So the water is added to the tank and the speed of the water waves in a deeper water is greater than speed of the water in a shallow. Frequency does not change. So state and explain how the wavelength of a deeper water has changed compared to the shallow water, which will have a higher, this is about the refraction. So in which case it will have higher greater wavelength. So in deeper it will have a greater wavelength than a shallow. That's right. Because in deep water it's traveling faster, so wavelength is also greater. But in a shallow water it's traveling slower, wavelength also decrease, but the frequency remain unchanged. Apart from a change in the wavelength, describe other difference in the pattern formed by the crest after the wave passes through the gap. So what happened, like as you can see, what we did now, we made this, apart from a change in the wavelength, describe the other difference in the pattern formed by the crest after the wave passes through the gap. Now the same wave is passing through a gap which is in a deep region. So when it is in a deep region is having a longer wavelength, means the wavelength is bigger as compared to the gap size. So when wavelength is larger than the gap size, then what we will observe, wavelength are larger or equal to the gap size, so we'll observe maximum diffraction, so greater curve or maximum diffraction will occur. Is it clear? This is a continuation of the question. In the beginning, because the wavelength was shorter, now what we did in this same question, they mention water is added to a tank. So when you add water to the tank, so it will be deep. So speed of the wave in a deeper water is greater than speed in a shallow water. Like first, we are observing this when the tank was having a small amount of water. Then we add water to the tank. So when we add water to the tank and observing the same phenomena, so when we are observing the same phenomena by adding water to the tank, in that case, the wavelength of the water waves will be higher, because in a deep water, the wavelength is greater, speed is also greater. So as now you can see, the gap size and the wavelength are approximately equal, or gap size is smaller as compared to the wavelength. So what we'll observe maximum diffraction or greater spreading of the wave. Is it clear, this part? Amplitude of the wave, amplitude actually depends on how much energy the wave is transferring. So amplitude, like example for sound waves, if it were, in this case it is a water wave, but it can, if it was a sound wave, then for sound waves amplitude decreases as the wave travel, even if not diffracting, the amplitude or the energy decreases. So amplitude of the wave, it's an independent factor. It is not affected like whether diffraction occur or not. But normally if there is more diffraction, then amplitude is smaller, because the energy is spread out. shows the successive crests of the water waves approaching a narrow gap. So you have to complete on the figure, draw the three crests that have just passed through the gap or the barrier. So if it's a narrow gap, if gap size is smaller or equal to the wavelength, then maximum diffraction occur. So you will show greater spreading or curve. Figure 6.1 shows the crest of the wave in a sea as it reaches the entrance to the harbor. The wave reaches the gap and passes through the harbor. On the figure, draw first three crests on the right of the harbor. So what you have to check? You have to check the wavelength and the gap size. So here, as you can see, the gap size is larger than the wavelength. So it means that small diffraction. So how to represent a small diffraction? This is how we represent small diffraction, means the wave spread out less. If it's more diffraction, then we will represent by a curve. A wave with a larger wavelength approaching the harbor. Now the second wave reaches the gap and passes. On the figure, three crests. So as you can see, the wavelength is larger than the gap size, or gap is smaller. So diffraction will occur, greater diffraction. So it will be curve. But one thing you have to keep in mind, using a compass, you will draw this. And if using a ruler, first you'll measure this wavelength. Example, according to paper size, if it is 2.5. So you will place a compass at the center and open the compass 2.5 and draw an arc. Then further 2.5 means open 5 centimeter, then draw an arc. Then open 7.5 centimeter and draw an arc. So you should draw a curve with an equal spacing using a compass, which shows that the wavelength does not change when it passes through the gap. Is it clear, this part? If wavelength is equal to the gap size or gap size is smaller than the wavelength, both cases you will draw the curve. Figure 6.1 represent the wavefront of a water wave. Figure 6.1 represent the wavefront of water waves on the surface of a water approaching a gap. So you can see when you measure the gap size, the wavelength with the gap size, the wavefronts to the right of the barrier spread out as far as the dashed line. So they represented that how they spread out. State the name of the process of spreading out, what we call when the wavefront spread out. What is the name given to this phenomena, spreading of the wave? We call that as diffraction. Then you have to draw 4 wavefronts to the right. But keep in mind, because as you can see, you measure the gap size with the wavelength. Here, wavelength is smaller and the gap size is larger. So it means it shows that there will be a diffraction, but small diffraction. And they already give you a hint that the dash or the dotted line is representing a diffraction part only. So how you'll represent this? And again, keep in mind the wavelength should not change. If this was 2 centimeter, then I should use a ruler and I should measure this distance should also be 2 centimeter. When you're drawing a straight line, you don't have to use a compass. Only when you're representing a small diffraction, draw vertical lines or parallel lines, because it's not necessary that always it will be vertical. It can be according to the question. So draw the vertical lines equally spaced according to the wavelength given in the question. And just make the curve or bend near the ends. State the effect of increasing the width of a gap in the barrier. If I increase this width, what will happen to the, how it will affect? Like if I increase this width, so it will, less diffraction will occur. Increasing a width of the barrier. State and explain effect of increasing the frequency. So increasing a frequency, the relation between frequency and wavelength are inversely proportional. If speed is constant, if you assume speed is not changing, because in diffraction, as the speed remains same throughout, so speed does not change. So we have the formula V is equals to F lambda. So, or V divided by F is equals to lambda. In a diffraction, speed does not change because it only changes a direction. So if I change the frequency, so if I decrease the frequency, means I will increase the wavelength. So when I increase the wavelength in this picture, what will happen to the pattern of the diffraction? In a diffraction, the speed does not change. So what is the speed before the barrier? Same is the speed after the barrier. So now what they're saying, if the speed is not changing, we have the formula V is equals to F lambda. If I increase the frequency, it means I will decrease the wavelength. Or if I decrease the frequency, it means I increase. Here they mentioned decreasing a frequency. So you have the formula V is equals to F lambda. So decreasing a frequency means increasing the wavelength. And increasing the wavelength, what will happen? So how it will affect the diffraction? So if the wavelength is larger than the gap size, so what we will observe? We will observe maximum diffraction, or wave will spread out more. So that increases the diffraction. Is it clear? So if we decrease the frequency, it means the wavelength of a wave is increased, and if wavelength is bigger than the gap size, so spreading will be more, or it will have a greater diffraction. Figure 7.1 shows a surface of water in a tank. The straight waves are produced on the left and travel towards the gap and become curved. Name the process that caused the wavefront to spread out. That is known as diffraction. That's correct. Suggest the cause of reducing the spacing of a wavefront on the right. Means the question is why when we see this one, the gap, the wavelength, and here the wavelength, why the wavelengths are not same? Normally in a diffraction, the wavelengths remain same, does not change. But why in this one the wavelength is decreasing? What could be the reason? The wavelength on the left hand side appear to be higher as compared to wavelength on the right hand side. What might be a reason why the wavelength is decreasing? The gap is less than the wavelength, that's why diffraction occur. But why the wavelength? Yeah, that's right. Because what happened, it looks like the water on the left hand side is deep and the right hand side is shallow. That's why, because diffraction does not affect the wavelength of the wave which is passing through. Wavelength is of a wave only changes if the medium changes. So it shows that water on the right hand side might be shallow. That's why the wavelength is smaller as compared to left hand side. State how a pattern of a wavefront on the right hand side change when the gap is made narrower. Means if we further reduces the gap. So the diffraction will, so it will have a large diffraction or increase the diffraction. So this is a topic, diffraction. Any doubt related to this diffraction part? So look, diffraction is maximum. Keep that in mind. In practical, the diffraction is maximum when the wavelength is equals to the gap size. But even you will consider for O levels, it is acceptable. You can consider if the wavelength is greater than or equal to the gap size, the diffraction will be maximum. And when the wavelength is smaller than the gap size, then it will be minimum. Here we have curves more spreading, and straight line, which shows less spreading of the wave. Any doubt related to the class today, the diffraction of the wave? So I'll end the session and share the recording. And there will be a test tomorrow of thermal physics multiple choice questions.